Hello students, now let us try to solve the problem, Intext problem of the acid, base and salt from the glass tinth and CRT book. So first question is, Intext question is there on page number 18 is there. What is first? You are given 3 test tube. The 3 test tube contain distilled water, acidic solution and the basic solution respectively. Okay. So, okay, try to understand here student. What are there? 3 test tube are there. Okay, so together you can understand. Here is these 3 test tube are there. So what they are saying is student, in first tube what is the distilled water is there, distilled. Okay. Another test tube is what they are student, acidic solution. It is acidic. Now what is there student, basic solution is there, basic. So now there is only red litmus. What litmus is? Red litmus paper is there, litmus, red litmus paper, right student? Red litmus paper available in order to identify what is there is each test tube. Okay, so red litmus is there. How will you find out what is the each of the test tube? Okay, so student, that is you are having the only red litmus. Okay, so student, if you are having the red litmus, so here if you are putting in this one, okay, distilled water. Okay, so let us read out firstly, then we will explain. We can identify the content in each of the tube using the red litmus paper. This can be done by noticing the color change of the litmus paper. If the red litmus paper change to blue solution, it is basic solution. So if you are putting the red litmus in this student, if you are putting the red litmus in this one, okay, in this one, so basic solution, so it will turn red to blue, it will convert red to blue student, red to blue. So this solution means what is, this will be the basic, right student? Next one, if the red litmus experience no change, if it is not changing student, so it is the acidic, because red to red, it will be red to red in case of the acidic solution. Last point, if the red litmus paper change to purple, the solution is distilled. Okay, so if you are changing what student, this is purple. So if you are changing the purple student, so this solution will be what? Distilled water. So this is how can you understand student, that point alone I am explaining here. If you try to understand, okay, here. So what point is there? Firstly, red to red, okay, red to red litmus, okay, red to red litmus, it will be what will be there student. If red litmus is there and it is again changing to red, so red to red litmus is there student, so this is the acidic solution. Okay, no change, acidic solution. Okay, if it was red to blue, red to purple, red to purple litmus, red to purple litmus, so red to purple litmus means what student? That is distilled solution, distill. Okay, distilled solution. And last one is there student, that is red to blue, red to blue litmus, red to blue litmus. So what would be there student? Red to blue litmus, it will be the basic solution. So by this we can be able to identify the three liquid ABC. Next point, let us try to understand student. Which gas is usually liberated when acid react with metal? Illustrate with an example. How will you test for the presence of this gas? Okay. So what they are saying, again read, which gas is usually liberated when acid, you are having acid react with metal. So acid react with metal student. So always it will give student, always you keep in mind salt plus hydrogen gas, H2 gas it will liberate. Okay, always. Suppose example, you see HCl acid, and if you are taking student Zn, okay, so what it will give student, it will give ZnCl2 2 mole and plus it will liberate the H2 gas. If you are taking student Na, okay, if you are HCl and you are taking Na, so what it will give student, it will give NaCl plus it will liberate half mole of H2 gas. Okay, if we are having the HCl student and you are treating with the Mg, so it will give, that is MgCl2 plus H2 gas it will liberate. So always it, and these are what student, these are the salts. Okay, these are the sodium chloride salts. So always when acid react with any metal, salt and hydrogen gas are formed. Metal plus acid, salt plus hydrogen gas. This is now. Metal compound A react with dilute hydrochloric acid to produce effervescence. Okay, metal compound A react with HCl and it producing what that effervescence, effervescence, effervescence. The gas evolve extinguish a burning candle. Okay, no, what the gas evolve extinguish a burning candle. Okay, write the balance equation, write the balance chemical equation for the reaction if one of the compound form is calcium chloride. Okay student, so it's a very nice question student that you have to try to understand. So a metal compound released a calcium chloride. So what is CaCl2 is there, the gas evolve will be CO2. Okay, that is why it is what extinguisher you are using the as a extinguish. Okay, so hence metal A should be calcium carbonate. It should be what is CaCO3, CaCO3, and it will react with the what is it will reacting with the HCl, and hence between calcium carbonate. So what it will give student, it will give that is what calcium chloride plus carbon dioxide plus water is there. Okay, so CaCO3 is there, it will be the 2HCl, CaCl2 plus CO2 plus H2O. So this will be the our correct answer students. That is how can you be able to. So this gas is used as a extinguisher, gas evolve extinguish burning candle. So whatever this one carbon dioxide is there, and it will what it will do is student, if it is the candle is burning student, it will be the extinguish extinguish burning candle. Okay, next point. Okay, in question number third, why do HCl, HNO3 etc. show acidic character in the presence in aqueous solution, while solution of the compound like alcohol, glucose do not show acidic character? This is also quite good question student. See, in if you are taking the HCl student and you are putting in the water, so it will give the H plus ion. If you are taking HNO3 student and if you are putting in the water, it will also give the H plus. So what they are saying, since it is giving in the H plus, that is why ionization is taking place. So it will be act as a acid. Okay, acid. So you see, release of H plus ion in water makes the compound acidic or non-acidic. Acid are the substance which upon dissociating with water results in the production of hydrogen ion. Some compounds show acidic character as they dissociate in aqueous solution, which results in the production of hydrogen ion like HCl and HNO3. Compounds similar to glucose or alcohol do contain hydrogen element, but they do not show signs of acidic nature. The fact that hydrogen in them will be separate as like the hydrogen in acids. They will not separate to become hydrogen ions on dissolving in the water. Hence, dissociation of hydrogen gas will decide the acidic or non-acidic nature of the H plus ion will decide the acidic and non-acidic nature of the compound. So these are giving the acidic nature. But if you are putting the alcohol, if you are taking the alcohol student, so if you are dissolving it water, it does not give H plus ion. Okay, does not give H plus ion. So if it is not giving H plus ion, so it will not be acidic in nature, right? This is our required answers, right student? Now let us try to understand what next problem is student. Why does an aqueous solution of an acid conduct electricity? Why does an aqueous solution of an acid conduct electricity? That is also simple answer is there student, because aqueous solution of acid is having ions, and ions are the carrier of electricity. So here we can read out student, charged particles are responsible for the conductance of electricity in acid. The charged particle called ions are the region behind the conductance of electricity in acid. Why does dry HCl gas not change the color of the dry litmus paper? HCl does not give out hydrogen ions, therefore HCl does not show any acidic behavior, and color of the litmus paper remain the same on reacting with HCl. Okay, so this is our the answers. What will be? Why does HCl, dry HCl, not change the color in dry litmus paper? Because it is not dissociating student. HCl does not give hydrogen ion, therefore HCl does not show any acidic behavior, and color of the litmus paper remain the same. Next one, while diluting an acid, why is it recommended that the acid should be added to water and not water to acid? What they are saying again, student, why distinguish no while diluting acid, why it is recommended that acid should be added to water and not water to acid. Okay, so let us see, student, while diluting an acid, it is recommended that the acid should be added to water and not water to the acid, because water is added to concentrated acid, it releases the huge amount of heat which may result in the explosion and can cause acid burn or burns or face, clothes and body part. Hence it is safe to add acid to water but not water to acid. So student, always you see that is it is a water is there, H2O, and you are adding that is H2SO4. This is the correct method. But if you are having that is, if you are having the H2SO4 and you are supposed to add the H2O, this is wrong, student, because it will give the heat and this heat will burns you. So that is you have to keep in mind. Okay, next question, student, how is the concentration of hydronium ion affected when a solution an acid is diluted? Okay, student, so read out the point, student. When acid is added to water, there will be fixed amount of hydronium ion present in the fixed volume of solution. If we dilute the solution, hydronium ion per volume of solution decreases. This in turn decreases hydronium ion concentration in the solution. This in turn decreases hydronium ion concentration in solution. Okay, so when you are having the H3O plus, student, you are H3O plus, and if you are adding the water, student, so it will the concentration of H3O plus ion will decrease. H3O plus ion will decrease. Okay, ion will decreases. Okay, next point, how is the concentration of hydroxide ion is affected when excess base is evolved in solution of sodium hydroxide? Okay, so when base is dissolved in the sodium hydroxide solution, its hydroxide ion increases, but it will reach saturation at some point. Okay, what they are saying, how is the concentration of hydroxide ion affected when excess base is added to the solution? So OH ion is already there and you are adding the base, student, base, and how much excess base you are adding. So what is happening, when base is dissolved in sodium hydroxide solution, its hydroxide ion, but it will reach to saturation point, it will be the saturation point. Okay, saturation point. So what will happen, student, if it is reaching saturation, after saturation point, hydroxide ion concentration is not affected even after adding base further. Okay, so when you are adding the excess, one saturation point is achieved, again you are adding the excess base, nothing will happen. After the saturation point, hydroxide ion concentration is not affected even after adding the further base. So this we have to keep in mind. Next question is in text number 4 is there, student, page number 33. So let us read out this problem also. You have two solutions A and B. The pH of solution A is 6 and pH of solution B is 8. Which solution has more hydrogen ion concentration and which solution is acidic and which is basic? So dear students, you see, so A is there, this is B, and here is pH how much, 6, and here pH of B is 8. So this is basic, student, this is basic, and this is acidic, and acidic is having what is, student, H plus ion, and base is having OH minus ion. So this one is having the more H plus ion. Okay, let us see, student. In order to find the hydrogen ion concentration, we can use the rule that state the pH of any solution is inversely proportional to hydrogen ion concentration. Okay, therefore it means that solution that has lower pH number will have higher hydrogen ion. So this one pH is lower and more, this is H plus ion is more. Hence solution A will have the high hydrogen ion concentration. In adding solution B will be the basic and A will be acidic, right? Next point, you see, what effect does the concentration of H plus ion have on the nature of the solution? Okay, what effect does the concentration of H plus ion have the nature of the solution? This is the problem. What effect does the concentration H plus ion have on the nature of the solution? See, student, Hydrogen ion concentration decide nature of the solution. If hydrogen ion concentration increases, that turns the acidic solution will be acidic. Similarly, if hydrogen ion concentration is decreases, the solution will be basic. That is very easy, student, no need for explanation. Next point, do the basic solution also have H plus ion? If yes, then why are they basic? Basic solution has H plus ion, but hydroxide ion present in basic solution are more in basic solution. Hence hydroxide ion turns the basic solution. Okay, so that will, even H plus ion is there, that will be the less in the basic solution, student. Under what soil condition do you think a farmer would treat the soil of the field with quicklime, calcium oxide, slackline, calcium hydroxide, or chalk, calcium carbonate? Okay, let us see, student. If the soil is acidic in nature, pH below 7, then such fields should be treated with the quicklime, calcium oxide, and slackline, calcium hydroxide, and chalk, calcium carbonate. If pH is what, student, less than 7, okay, acidic pH, so these are what are the calcium oxide is basic, calcium hydroxide is basic, okay, calcium carbonate is basic. So at that case you have to use, if the pH of soil is less than 7, then you can use the calcium oxide, calcium hydroxide, calcium carbonate, etc. Next question number 5. Okay, what is there? What is the common name of the compound CaOCl2? Common name of CaOCl2 is bleaching powder, student. It is the formula is like here is the O, here is CaOCl2, that you don't need to go for the formula. That is the bleaching powder only used for the dry cleaning. Next one, name the substance which on treatment with the chlorine yield bleaching powder. Okay, name the substance which on treatment with chlorine yield a bleaching powder. The substance which on treatment with chlorine yield bleaching powder is calcium hydroxide. Okay, is calcium hydroxide. The substance which on treatment with chlorine, the substance which on the substance which on treatment with chlorine yield bleaching powder is calcium hydroxide. So calcium hydroxide is there, and if you are treating with the Cl2, student, it will give, that is CaOCl2 plus hydrogen gas will released. Okay, name the sodium compound which used to softening the hard water. Okay, the sodium compound used softening hard water is sodium bicarbonate, NaHCO3. Okay, let us see, student. Okay, where is the, okay, answers are not. Sodium carbonate, Na2CO3, student. Na2CO3 is the compound which is used to softening of hard water. Next point, what will happen if solution of sodium hydroxide is heated? Give the equation of the reaction involved. Okay, what will happen if the solution of sodium hydroxide is heated? What will happen if the solution of sodium hydroxide is heated? Give the equation. So sodium hydrogen carbonate, not sodium hydroxide. So it is there NaHCO3. If you are heating NaHCO3, student, so it will directly convert, that is washing soda, Na2CO3 plus it will convert H2O plus CO2. So here will be the 2. So heating sodium hydrogen carbonate yields sodium carbonate and carbon dioxide gas liberated in the process. Write the equation to show the reaction between plaster of Paris and water. So the chemical reaction for the plaster of Paris and water is this: plaster of Paris, and here is the water, so it will give the calcium sulfate, that is hydrated calcium sulfate. So that will be very solid. So this is all about the Intext problem of the acid, base and salts from the grade 10, student. Thank you so much for watching.